Hello, karibu SolidWorks Tanzania. Ni matumaini yangu umekuwa na lessons poa sana ambazo zimepita and we are still moving forward. I'm hoping kila kitu kimekuwa well understood and I have a hope that unajifunza vingi, unaelewa vingi, lakini pia unafanya mazoezi ya kutosha either kwa kutafuta tutorials kwa YouTube ama kwa Google and other sources ama kwa GrabCard etc. So today in this lesson we are going to learn about gear drives. So, particularly how to maybe create gears either by manually drawing the gears or by using the toolbox, right? But before we jump into the SolidWorks, tuanze kwanza na a short presentation to just to give us the foundation, like the overview about gears, right? Okay, so what are gear drives? So gear drives are mechanical systems that transmit power and motion between rotating shafts using intermeshing gears. So gear drive inakuwepo kwenye power transmission, right? Ni kama tulivyoona before, tuliona belt drive na yenyewe pia ni a means of power transmission, lakini ilikuwa ina base on friction drives, right? um, and we saw earlier kwamba belt drives haihitaji lubrication. Pia assembly yake ni easier, not that complicated, etc. So gear drives offers precise motion and torque control. Okay. Right, so what are the components of the gear drive? So in a gear drive, we have a driver gear. A driver gear is the one that is linked to the source of motion. Let's say it's a motor or a generator or an engine, right? And then we have the driven gear. So the driven gear is the one that receives the motion, maybe the speed, the torque from the driver gear. As you can see here in this gearbox or in just this simple sketching, you see we have a driver gear, gear A, and a driving gear, gear B. And you can see actually when two gears are linked, only two gears are linked, then the motion of the gears goes in opposite direction, right? So it's not the same as belt. Belt uliona connect a pulley to another pulley, two pulleys, the direction of motion or transmission of power or torque is in the same direction. But here it's reversed. But then we have a gear housing, like let's say this is a gearbox. Then we have the housing. This is the housing. Housing inasaidia to protect the gears against debris ama particles ambazo zinaweza zika affect ama zika cause wears, lakini pia housing ina act kama sump ya kuhold ile oil, gear oil, kwa ajili ya kupunguza friction forces, right? Higher friction leads to too much wear in gears, right? But then we also have bearings and lubrications, right? So we have lubrication system to take care of the friction, like we have the bearings. For example, hii gear hapa, unaona hii gear haipo, hii ni driven gear, hii ni driver gear. Driver gear labda iko linked to the motor, power supply ama engine, lakini driven gear unaona iko mounted kwenye bearings, right? Then it's moved by the driver gears. So what types of gears do we have? So we have this. These are the famous types of gears. So the first one is the spar gear. This is just a spar gear or straight gear. Then we have helical gears where we have the gear teeth slanted or inclined in a helix format. We have bevel gears. So these are bevel gears. So they differ in a way that the shafts are arranged, the gear shafts. For example, this is an intersection shaft. But for this one, this is a non-intersecting shaft but parallel shafts, right? And then we have worm gears. This here is a worm gear. You see, and this is a worm shaft, and then this is a worm gear, and then we have rack and pinion. So rack and pinion famously inatumika pia kwenye steering system ya magari, right, kuturn the wheels, right. So what are the gear arrangements? We have three main arrangements of gears. So the first one is the parallel shaft arrangement. So you see here, for example, these gears and these gears, the shafts that are in the gears are parallel to each other, right? So here we have the gear machines. But then we have intersecting shaft. So you see this shaft is vertical, this shaft is horizontal. So we call this intersecting shaft arrangement. So this is, for example, in these bevel gears. But then we have non-parallel and non-intersecting shaft. For example, this one, the shafts are neither parallel and nor intersecting, right? Like this one, which we saw earlier, which is worm gear, right? So what are the working principle? What is the working principle of a gear drive or gears, right? So gears transfer power through their engagement of teeth on two rotating elements. So you see here gear A, B, C. So you will see here the gears have teeth and the teeth are engaged to one another. So once the driver gear starts moving, for example, this is the driver gear that's move at 90 revolutions per minute, it drives the gear that is engaged to it, and like any other gear. So if you see here, the second gear rotates on opposite direction to the driver, but then we have a third gear that rotates in the same direction, like clockwise direction as the driver, but the middle one is in the opposite, so goes in the opposite direction. So you see, if you want to keep the gears moving in the same direction, you need a gear in between, which you call it an idler gear, right? So the direction, speed and torque can be altered based on the gear ratios and arrangements. So depending, kama tulivyoona kwenye belt kwamba ikiwa unataka kupunguza speed, inamaanisha pulley on the driver shaft should be smaller than the pulley on the driven shaft. Hapo utakuwa unapunguza speed, right? So that's the ratio. Lakini ukija hapa kwenye gear ratio, so gear ratio says that the gear ratio is the ratio of the driver to the driven gear, right? So if the diameter of the driver is bigger than the diameter of the driven, then we are doing gear reduction, right? Because now no, so here is the driven to the driver. Yes. So you see this is the driven gear, it's the drive gear. So this is the drive gear, it's the driven, sorry. So the gear ratio is the ratio between the driven to the driving gear. All right? So na hizi gear kulingana na diameter zinatofautiana pia number of teeth. So bigger diameter, more or less we expect more number of teeth than a smaller diameter, right? Kwa mfano ukiangalia hii gear ambayo ni driven gear ina 16 teeth na hii driving gear ina 8 teeth. So ukichukua driven over driver unapata 2:1. That's a gear, it's a gear reduction, right? It's a gear reduction. What do we do? Do we reduce? We reduce the speed, right? Hii hapa ikiwa na rotate at a high speed, hii kwa sababu ni kubwa na ina many number of teeth, ita rotate at a low speed, right? Hii inakuwa kama ni kama kwenye gearbox ya gari kwamba kama hii tuseme hii inaweza kuwa gear namba, hii ni gear namba, hii hapa ni gear namba 3, labda hii ni gear namba 1, right? No, so hii ni gear ambayo ina rotate, inachagua ni gear selector, right? So hii gear selector kama ni ndogo kuliko selected gear, manake tumeweka low gear. Low gear manake tunakuwa na high torque, right? High torque but low speed, right? So they go vice versa. So hii ni speed ratio. So that means kwa torque ratio, the torque here is higher than the torque of the driving. So ukija hapa chini ni overdrive ambao the driven number of teeth in the driven gear is less than the number of teeth on the driving. That means we are overdriving, like hii big gear In a rotate small gear, that means small gear will be rotating faster than the high gear, right? So 1:2. So as you can see here too, right? This gear is rotates faster than this one because this is overdrive, 1:2. One revolution here, two revolutions here, because this has twice the diameter of this, or twice the number of teeth of this. So what are the advantages of gear drive? First, gears have high efficiency. High efficiency ni kwamba we do not expect lots of power losses, either power or speed or torque. We expect a very efficient transmission. Ukilinganisha na belt drive ambayo belt ikiwa imewea ama imeishaisha inaweza kuwa ina slide on top of a pulley, so inakuwa ina lose some power. So that means the efficiency decreases on belt drive. Lakini kwenye gear drive we always experience high efficiency. Lakini we have accurate and constant velocity ratio. Like if it's 1:2, it's 1:2. If it's 2:1, it's 2:1. Like it's always accurate. Lakini it's also a compact design. The compact design in a sense that it's a perfect fit or match of the transmission system, right? But it can also transmit high loads. Kama unakumbuka kwenye belt tulisema kwamba belt haiwezi kutumika kwenye high loads. Well, maybe inaweza ika snap, maybe inaweza ika slide. The friction is not enough to carry huge loads. The torque is not so much. Lakini gears, well, gears are strong, right? Gears, they can withstand high torque, high loads, you know. So that's why unakuta hata kwenye magari kuna magari ambayo yana gearbox za CVT, CVT continuous variable transmission. Manake ndani ya gearbox kunakuwa kuna belt, wire belt, right? So hizo gari zinakuwa na high speed lakini low torque. They are not for towing things. Lakini ukita gari na gearbox ambayo ni automatic transmission gearbox, right? AT, then hii hapa inakuwa ina high torque, hata pulling power yake ni kubwa, then inaweza ika lift ama ika tow heavy things. So what are the disadvantages? First, gears are noisy. Yeah, ukilinganisha na belt, gears zinapiga kelele. So sasa kukiwa hakuna lubrication ya kutosha zinapiga kelele, ama hakuna soundproof ama housing ambayo ni heavy, utazisikia. Lakini pia ina require lubrication, that means it's expensive to maintain or to service. Like usipoweka lubrication, then gears zitawear, then utaikaa even more cost to retain their capacity. Lakini ni very sensitive to misalignment. Like gear kukiwa na any misalignment inaweza ikagoma kabisa kutembea. Like kama teeth hazina perfect match, inashindwa kabisa kutembea. Lakini pia ikitengeneza corrosion between the gear teeth inaweza kuwa ngumu sana kuanza kutembea unless una remove ile corrosion. Lakini pia gears are more expensive to manufacture kulinganisha na belt. Belt tu una cast your pulleys, then unaweka tu belt, you're good. But gears, well, depending on the material of the gears, well, they are expensive to manufacture. So what are the applications of gears? So first, in automotive transmissions, kwa mfano gearbox ile ya kubadilisha gears, kuweka low gear, high gear, kutegemeana na mahitaji. Kwa mfano, lakini pia kwenye differential, ukiangalia kwenye differential, this is an automobile differential gears ambazo zinasaidia kupeleka motions and torque kwenye wheels au kwenye tires za gari yako. Hii hapa ni gear ambayo imetoka kwenye propeller shaft ya gari ambayo inapeleka kwenye rear wheel drive. Inaweza kuwa rear wheel drive ama four wheel drive. Lakini pia inatumika kwenye magari kama kwenye steering system. Kwa mfano ukiangalia hii hapa ni hydraulic steering system ambao hapa chini kuna rack and pinion. Rack and pinion, wakati una turn your steering inapata assist from the hydraulics to push the shaft that goes to the tire rods, so as you have an easy turning of the wheels, right? Lakini pia kwenye industrial machines, many machines zinakuwa na gears kama power transmission, right, ama torque ama speed. Lakini kwenye clocks and watches, kwa mfano ukiangalia hizi ni gears ambazo zipo kwenye clocks and watches. robotics. Follow this is like a robotic gear, etc., etc. Well, so what are the maintenance tips? First, let's say you have a gearbox or a gear system. First, you need to check your lubrication levels time to time. Kwa mfano, kuna zingine ambazo ziko ndani ya housing, lakini kwa gear ambazo ziko nje ya housing unaziwekea greasing, right? Unaziwekea greasing kupunguza misuguano, kupunguza friction. Lakini inspect for gear tooth wear, kwa sababu kama kuna wear then inakuwa ni risky, inaweza ikaendelea kumfanya more wearing of the gear teeth, alafu ikaleta shida. Lakini monitor alignment, make sure the shafts are perfectly aligned, hakuna misalignment, ili kufanya ile smooth transmission of power and torque. Lakini replace the damaged gears. Kama una gears ambazo wear, many yamevunjika, just take them out. So before finishing, on the right, this is a nomenclature of a gear. It's a very important nomenclature of a gear. It's good to understand. So you can see from the top here, we have a pitch, right? A pitch is a distance between this center here to this center here, between the center of the gear teeth, can be that. We have face width, this is the width of your teeth. We have the top land, this is the top side of the teeth, face and flank, right? We have addendum cycle, pitch addendum cycle, we have etc. And then we have down here, we have pressure angle. So this is the pressure angle here, right? This is the pressure angle. And then this is the tooth face, right? And then this is a pitch between this point and that point. This is the pitch of the gear. And then we have a reference line, and then we have yeah, root face. Okay. So we have an important definition here, a gear module. So what's a gear module? So a gear module is a size parameter that determines the tooth size and pitch. So it determines this distance is how much, but the size of the tooths too. How big is it? So the pressure angle is the angle between the line of action. So the normal reference line, the line of action, and force direction, right? And the tangent to the pitch cycle, tangent to the pitch cycle, right? This here, this is a pitch cycle, right? The pitch cycle, tangent to that pitch cycle, right? This is the tangent to the pitch cycle, right? Those are key parameters in gear design and are related. The pressure angle influences the tooth shape and the strength. So pressure angle hii hapa inaamua shape ya hiyo tooth. Kwa mfano unaona hapa, this is a different shape, right? Kuna pressure angle yake, lakini hapa this is a different shape, pressure angle. But also influence the strength of this, all right? So the sharper, maybe not so strong, but the caviar may be very strong. So while the module affects the overall gear size and tooth dimensions, so module is normally said by a number and determine overall dimension of your teeth, of your gear. Bravo! So there you have a very good foundation about gears. All right. So now we can go forward and open our SolidWorks, right, and see what we can do from here. So kama nilivyosema kwenye SolidWorks unaweza ukachora gear, like unaweza ukaisketch, right? Unaweza ukaichora gear from the like from zero, right? Lakini pia unaweza ukatumia toolbox, right, ku create gear. So I'll start with developing a gear. So where do we start? Let's go to front plane, say sketch, right? Tutumie tu intuition. Unaweza kuwa na accurate dimensions, lakini for the sake of learning, tutumie tu intuition tuchore gear. So let's create a spar gear. It's a straight gear. So you will explore the rest of the gears. They are almost the same. So let's start with cycles. So let's say here and then here. Smart dimension. let's say the outer diameter is 100, and inner diameter is let's say 80. All right, let me draw here a center line kutokea hapa mpaka hapa. So naweza chora tu approximately a line from here to here. Sorry, Control Z. Chukua line from here to here. So smart dimension. So let's say from here to here is this is, let's say, 3, and let's say this is from here to here, let's say to here, let's say this is 7. Okay, let's mirror this. So this one, mirror mirror about this line. Okay, check. And let's do trimming. So trim this one. Oh, okay. Yeah, and then also trim this one and that one. Okay, so to make create one of the gear tooth. So hii hapa ili iwe all over, tunaweza tukai circular pattern. So here circular pattern. So select this line and that line and that line. Add here, let's say 11, 12. Let's say 12. Yes, let's say 12. Check. 12 teeth, right? And then let's do trimming again. So trim here, 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 and here. Okay. Okay, so tunaweza tukaweka sehemu ya shaft. So shaft tuseme itaingiza shaft hapa ya 40 diameter. So smart dimension. So this is, let's say, 40. Okay. So hii shaft tuseme itafungwa na hii shaft ya kwenye gear press fit, lakini itakuwa ina pin, inakiwa pin, right? So tuweke pin opening. So let's say pin of let's say this is 6, or let's say this is 8, and 8 by, let's say, 10. Yeah, let's give it some fillets of, let's say, 1 radius, and then this edge and that edge. Check. Okay, so trim this one, trim that one, trim that one. Okay, beautifully. Right, so now we can extrude it. So let's say extrude it base, extrude it by 20. And say check. Voila, there we have our spar gear, like that, right? I think the shaft diameter is so much. Let's say, let me lower the diameter of the shaft. So let's say this is 30 diameter. Okay, yeah, better. All right, yeah. So this is just a simple spar gear that I created. It has 12 teeth. Yeah. So naweza ongezea some features here. Say sketch. Yeah, just to make it look good. Let's say 1, 2. Smart dimension. Let's say this is 70. Let's say this is 50. Okay, and say features extrude. Extrude cut. So let's cut. Okay, let's cut. Okay, this sketch features. Sorry. Okay, I want to cut this slot here. Okay, Control Z. Right, features, extrude cut. Yeah, yeah, that's it. I want to cut it by 5. Check. Then say check. Yeah, that looks good. Naweza ikata pia upande huu wa pili, the same slot. Say sketch. Naweza click hapa niseme convert entities. Hapa nimepata outer cycle. Naweza click pia this inner cycle niseme convert entities, itatokea upande wa pili. Then from there features, extrude cut. Alright, extrude cut by 5 again, say check. Yeah, so I have a uniform gear like that. Okay, so there we have our gear, right? There we have our gear like that. And yeah, so what else? So here maybe I can give it some appearance, right? Appearance, metal. Let's say this is, let's say bronze. Let's say polished bronze. No, brushed bronze. Yeah, brushed bronze look like a nice color. And then let's say Control S. So let's save this to desktop and save this as a spa gear. Spa gear. Save. Okay, so there we have our spa gear. Sasa nataka kwenda kufanya assembling ya gear. Hii one gear, same gear, right? I want to assemble it in SolidWorks and animate it, right? Animate it, right? So tunatoka hapa tunakuja kwenye file, tunasema new assembly, okay, and then nachukua spa gear hapa, hii hapa. So hii ni fixed part. So just for the learning, right? Hii spar gear ilitakuwa iwekwe kwenye shaft. Shaft yenyewe inaweza kuwa inatoka kwenye motor ama kwenye engine ama kwenye power source ambao mtu ako nayo. But for the sake of learning, I will assume okay, this first spar gear, this is my engine shaft out, right? So engine shaft out imekuja hapo, so hapa nita insert another spar gear, nitaiweka hapa, lakini ilitakiwa kiuhalisia nichore shaft ndo ni assemble shaft iingie kwenye motor alafu ndo ni animate movement, but for the sake of learning, kwa sababu ushaelewa namna ya kufanya assembling, I'll just do my intuitions here. So assembly, insert component, so insert another spar this here, ama ningeweza nikacopy tu hapa kama tunavyojua, una hold control, una hold part, una click part afu una drag side as by the side tap like that, right? Ningeweza kufanya hivyo. So okay, so what I'll do, so first nataka kumate so mate this one, all right, and this one. So mate this one. Okay, check. Okay, so lakini pia nataka kumate this surface. Okay, this surface, say mate with that surface. Check. Right. So I want to make sure like my gear rotates freely, right? So let me check. Is it not? Oh, it's rotating. Yeah, so it's rotating. Okay, so now nataka pia kumate hii, unaona hii gear nataka kuimate na hii gear, but I can mate them first side by side before mating them concentric. So naweza sema here, niseme mate with this face so that they are in the same face, right? and then I can drag this away. So kitu naweza fanya, naweza click hapa alafu niseme normal to that, right? So you see I have here, so I want to mate these gears. So what can I do? So first hii naweza kuizungusha sababu ilikuwa kwa ile another gear, right? So ili ku make sure kwamba hii imemate exactly at the center, naweza sketch a line ambayo itatokea center hapa, alafu hiyo line ikija hapa center nitaimate na hii other gear pale ambapo unaona this is the correct distance. Lakini kama unafanya design drawing, maana yake utakuwa umeshafanya hayo mahesabu, unajua hizo gears zimekaa umbali gani. So naweza click to this face niseme sketch, ikisema warning, that's okay, that's fine. Then I'll sketch a line from this center to somewhere, a straight horizontal line. Let me assume the dimension here, sababu siko sure. Let's say 91. All right, check. So what I'll do, so I'll save the sketch. So kitu nitafanya sasa, I will mate. So see this center point, I say mate with this. So I'll say concentric, right? Then check. So that means this now is also moving and this now is also moving. Mwana, just for the sake of learning, hii ingeweza ikawa labda ndo inaendesha labda machine components, hii ipo kwenye power source ambayo ni motor, right? Sasa hapa naweza nikaziweka at a point where zinaonekana like they can now. Okay, let's say click here, say normal to. So naweza nikai position before I make them mate as gears, I can position them at a point where they look like they are meshing, right? So now I can mate these two as gears. So here per line naweza nikasema hide, right? Like that. So now na click hii surface nasema mate, lakini nitafuta hii mate, delete, nitashuka chini, nitakuja hapa kwenye mechanical mates, nitachagua gears. Nikichagua gears, nitakuja hapa nitachagua surface za gears. So nitachagua either inner ama outer diameter. So let's say this inner diameter and that inner diameter. Right. So ukiangalia hapa utaona imesema 30:30. That means ile inner diameter ni 30:30. So 30:30, that means it's 1:1 actually, kwa sababu hizi ni gear ratio, so it's 1:1. So hii kama ingekuwa kubwa kuliko ile, say this is twice the dimension of this, hapo ungeona labda 60:30, umeona, etc etc. And then after that say check. So mpaka hapo unakuwa umeshafanya gear meshing. So if I rotate any of these gears, the other one will also rotate. So are you ready? Let's go. 1, 2, 3. Oh yeah. This is beautiful, right? So forget the back gear. So this gear I use it as just for the positioning of this other gear. Hii nimeassume labda ndio motor ama ndio shaft ya motor ama shaft ya kutoka kwenye engine. So yeah. So you see so your gears, and as you can see, like this, the gear rotates like opposite, like not in the same direction, in opposite directions. So what if we want to have the motions in the same direction? That means we need a gear in between these two. So we can make this an idler gear, which is between the gears, and we can position another gear here, or we can position on this side, right? We can position another gear on this side. Okay, so let's do that. So control, create another gear like that, and say, okay, this one mate with this one so that they are aligned on surface. And then I can say normal to this surface, and then now I can again draw the line. So I'll click this face, I'll say sketch. Don't worry about this. Take a line kutokea center hii hapa, just a horizontal line, right? So distance kadiria ilikuwa ni 91. Okay, check. So I have to say my save sketch. So now I can say right, I can click this point and say mate with this cycle concentric. All right, check. So you see, there we are, there we are. All right. Then I can hide this. Now I want, if I rotate any of these gears, the gears that I'll mesh, um, they will be rotating together, right? So I have to mesh the other one, right? Okay, okay. So here's what I'll do. Na usiwaze hiyo meshing inaonekana sio perfect sana, hizo teeth, kwa sababu ni I created the gears out of intuition. Sikufata ile pressure angles, sijui pitch, sijui nini, sikufata. Okay, so I'll click this face, I'll say mate, and I'll say delete this one. I'll just go down, select mechanical mates, gears, and then happen to select this face and that face. So 30 ratio rush 30 again, that's okay. Check. Right. So now what? Now if I rotate this gear, this one will also rotate in the same direction as this gear because we have a gear in between them, an idler especially. So let me rotate this. See? Beautiful, right? Oh yeah. Uh-huh. So yeah. I hope umeelewa sana. So hii ilikuwa method number 1 ya kucreate gear. So method number 2 ya kucreate gear ni from the gearbox. Unaweza kuwa uko hapa kwenye assembling, and then we can create another gear here. Just not from the gearbox, from the toolbox. So click here, design library, click toolbox, say add in. Let's go to ISO standard. Let's go to power transmission, then gears. Let's just create a spur gear. Unaona hapa kuna internal spur gear, kuna helical gears, kuna racks, kuna straight bevels, right? So let's just create a spur gear. So what do? You do drag drop and you edit the values kama tulivyofanya kwenye bearings. So drag drop here. So nime drop hapo. So ukija hapa chini sasa unachagua module. So kama tulivyosema, module ina determine size of the gear, how big it is, how it looks. Najua kwa mfano hapa tukisema module 20, umeona tumepata bigger diameter, bigger teeth, right? But if we say module 8, we have just a lower diameter, smaller size. Number of teeth, hiyo gear kwetu ilikuwa na meno mangapi? If I remember ni 10, right? Let's say 10, but that looks few. So tufanye meno 14, yeah, maybe 14, right? Alafu pressure angle, let's say 20. Unaona pressure angle inaongeza hii slant ya hapa, hii hapa. Let me say pressure angle hapa 14 point. You see, it's not that slant, right? Okay, let's say 14 point. First width, well, width ni sawa na ile niliyochora before, so unaweza ukasema hapa 40. Unaona itakuwa face width inaongezeka hapa. Okay, so let's just say 20. All right, hub type. So kuna type tatu za hub. So kuna type B, you see this is type B. Unaona huku ina extension ya kuvalisha shaft ili huku iwe free, right? Alafu kuna type C ambayo yenyewe iko both sides kuvalisha a through shaft, right? So let's say this is type B, right? That's cool. And then overall length, so let's say overall length 50. Okay, nominal shaft diameter, so what shaft fits in. Kwa mfano zile zingine ziko na shaft ya 30, so unaweza weka hapa 30, right, ili ziwe sawa diameter na ile pale. keyway yeah, kama zile nilizoweka keyway. So rectangular ama unaweza kuweka two keyways, ukiweka rectangular 2 hapo unaona kuna two keyways, lakini hapa let's say kusema none au ina keyway, maana press fit ama welded, lakini rectangular 1 ina one keyway. Show teeth yeah, show jina la hiyo ni isosparse purpose, let's say check. Ukisha create kama hivyo, unaweza ukaiposition tu hapo, unaweza position as many as possible, then una escape. So we can delete. I need only one here, right? So this is the spag here. So hii ni spag ambayo unaweza ukasema edit part na ukaisave as an individual part. It's possible, right? Yeah, ukija hapa ukisema edit part. Assembly, okay, let's save the assembly. So let's say gears assembly, kwenye desktop, save. Is opened, read access not available for write access. Okay, no worries, so uh, not necessary to hii ni read access only, sababu nimecreate huku, lakini ukienda kwenye part drawings, kwa mfano achana hii assembly, part drawing pia unaweza ukatumia hii design library, ukaingia kwenye toolbox ukacreate gear, ukaidrag drop, alafu ukaiedit, ukaifanyia chochote, ukaiwekea holes, ukafanyaje, like you can do that, right? So let me just try to mesh this with the rest of the gears. So here say mate with this face so that they are aligned, and then say check. Let's say normal to this gear looks so big. All right, let me say here. Whoa, looks big. Sababu ya module. Okay, so naweza chora hapa ile line, nikuja hapa niseme sketch. It's okay. So sketch a line from this center to this. Let's say this is center. So smart dimension, let's say this is 104, 104. Enter. Okay, then save, and then hapa naweza chukua hii hapa, seme mate with this surface, seme concentric, oh sorry, this one and this surface concentric, check, and then check. All right, I think yeah, that's fine. Okay, so naweza hide hii hapa, hide this again, naweza sema tu this one mate, so naweza delete here, nakuja tena kwenye mechanical mate gears, na select this face and that face, yenyewe create ratio hapa. Okay, check. So if I rotate this, everything rotates, right? Yeah. So what can I do here? I can naweza animate, right? Naweza kuja tu hapa kwenye motion study, alafu nikaweka time baba 10 second, right? Alafu nikasema motor, nikasema motor ifungue kwenye hii hapa ambayo ipo kwenye motor, izunguke that direction, RPM 100 RPM rotary. Okay, alafu nje hapa niseme calculate. Yeah, so there we are. As you can see, hizo gears ambazo ni zina less diameter ama ni ndogo zina rotate faster than the bigger gear kwa sababu this we call reduction, right? Yeah, reduction kwamba the driver gear is smaller than the driving gear, so yeah, right. So yeah, I hope umejifunza vitu vingi. I hope umeenjoy the lesson. Um, yeah. So here, so keep moving forward, keep pushing, keep doing lots of practices and exercises, and you will get far. So until next time, see you at the top. Ciao.